Hello everyone. In this video, we're going to explore more work problems about the sinusoidal function. Alright, question 17 right here. Point P is located at the end of a large gear. Alright, so it's point P right here. At time t equals 0 seconds, the point P is directly below the center of the gear and is 4 inches above a level surface, as shown in the figure. Alright, so the distance from here to here is going to be 4. Point P is 6 inches from the center of the gear, right? So the distance from here to here is going to be 6 inches. So then the distance from here to here is still 6 inches, right? The gear completes 1 revolution in 2 seconds. Alright, so this one tells us that the period is 2, right? So we have period equals time divided by number of rotation, right? Alright, so it's gonna be 2 seconds divided by 1 revolution, right? So it's gonna be 2, right? Which of the following could be an expression for the function h of t, right? Alright, so we just use the formula right here. Amplitude equals maximum subtract minimum divided by 2, right? So A equals maximum is going to be right here, right? Minimum is going to be right here, right? So minimum is going to be 4 inches, right? Maximum is going to be 4 plus 12, right? From here to here, 6. From here to here, 6. So 16 minus 4 divided by 2. Alright, so it should be 6. Now, we need to find the midline. The midline, it should be D equals maximum plus minimum divided by 2, right? So it could be 6 plus 4 divided by 2. So it could be 10, right? Now, since we have the period is 2, right? So we need to find B, right? So B equals 2 pi divided by period. So it's going to be pi, right? So we know that the standard equation of the sine and cosine function is going to be right here, right? So we just match them up. So the answer must be D, right? Now let's move on to the next example, number 18. Right? This is the starting point. At time t equals 5 seconds, 20 rotations of the spinner have been completed, right? So this tells us that the period is 5 divided by 20. So it's going to be 1 over 4, right? Remember, we need to use this formula right here to find the period. Alright, which of the following function is an appropriate model for this situation? Take a look at this one. A sinusoidal function is used to model the x-coordinate of the position P as a function of t in seconds. Alright, so the y value, which is the x-coordinate, so keep that in mind. This is the y values. The x values is time t, right? So we have the period is 1 over 4. We need to divide 1 over 4 into 4 quarters, right? So we have 1 over 4 divided by 4. It turns out to be 1 over 16, right? We just multiply the top and bottom by 4, right? So 4 and 4 right here cancel out. So we have 1 over 16, right? Now, be careful. Point P rotates counterclockwise, right? Now, at point P, you project down to the x-axis, and you see that the x value is 0, right? they say that the x coordinate of the position of P is the y values, right? So at t equals 0, s equals 0, right? So 0 right here is the midline, right? So this is 0. The minimum right here is negative 15 if point P go over here. The maximum is right here. It's going to be 15 if point P go over here, right? So this guy should be 15. This guy should be negative 15. And this is the S coordinate. Right, so at point P, S equal to 0, T equal 0. Alright, so point P should be right here. So T equals 0. Now, when point P goes over here, which is the x coordinate is negative 15 and t equals 1 over 16, right? Which means 1/4, right? So this guy should be 1 over 16. Alright, if point P goes over here and then you project down to the x-axis and then s equal to 0, right? S equal to 0, which means it's right at the midline right here. And t equals 1 over 16 plus 1 over 16. It's going to be 2 over 16. And if you simplify, it's going to be 1 over 8, right? Now, if the point P keeps going over here, you project down to the x-axis, it's going to be itself, right? So the distance from here to here is 15, right? Which is the maximum. So point P should be right here. And then time t is 2 over 16 plus 1 over 16 should be 3 over 16, right? So right here it's going to be 3 over 16. Now if point P goes back to the original spot, right? So when you project down to the x-axis, it's going to be 0, so which is the midline right here, right? And time t right here, 3 over 16 plus 1 over 16 is going to be 4 over 16, which is 1 over 4, right? Now we need to calculate the amplitude, right? So we're going to use the formula right here. Amplitude equals maximum subtract minimum divided by 2. So A equals 15 subtract negative 15 divided by 2. So it's going to be 15, right? Next one, we need to calculate the period. So the period is 1 over 4, right? So then we use this one to solve for B, right? So B equals 2 pi divided by period, which means divided by 1 over 4, right? So we're going to multiply the top and bottom by 4, right? So then we simplify this one. So the answer is 8 pi, right? Now we look at this one right here. We need to eliminate the wrong answers A and C, right? So we have 8 pi and 8 pi right here. Now look at this one. We have the subtraction sign in front of the function, and this one doesn't have subtraction sign. And we look at the graph right here. It's going to be reflected over the midline, right? The sine function should be like this, right? And if it's reflect over the midline, you should have the negative sign in front of A, right? So the answer must be B. Now let's take a look at the next example, example number 19. Alright, example number 19 is similar to the example number 18. The only thing different right here is the period and information right here. A sinusoidal function is used to model the y-coordinate, right? In example number 18, it's going to be s-coordinate of the position P, right? Alright, so we have the period is time divided by number of rotations. So it's going to be 10 divided by 30. So it's going to be 1/3, right? We're going to divide 1/3 by 4, right? So it should be 1 over 12, right? So each quarter has 1/12 seconds to complete, right? Now, we need to sketch the sinusoidal function for this spinner, right? So, it's gonna be like this. At t equals 0, the spinner begins to rotate, right? So at t equals 0, point P is right here, right? Now, since the sinusoidal function is used to model the y-coordinate, right? So we need to project on the y-axis, not the x-axis anymore, right? In example number 18, we project the point P on the x-axis. Now, this is on the y-axis, so keep that in mind. So right here, you must have the y-coordinate. Alright, now, at this point is the highest point, right? Because the distance from here to here is going to be 15. Distance from here to here is going to be negative 15, right? And right at origin right here is going to be 0, right? So 0 is the midline. So 0 right here, this is 15, and this is negative 15, right? Now, point P is the highest point, so the highest point should be right here, right? And right here, t equals 0, right? Now, point P rotates counterclockwise, right? So it's going to be right here. If point P goes over here, the time t equals 1/12, right? So right at this point, you project down to the y-axis, right? It's right at origin, which means the height is 0, right? So it's going to be the point at the midline right here, and t equals 1/12, right? Now, if point P goes over here, you project down to the y-axis, it's going to be itself, right? This is the lowest point. The height is negative 15, right? So the lowest point right here. Alright, t equals 1/12 plus 1/12. It's going to be 2/12. 2/12 equals 1/6, right? So I have 1/6 here. Now, next one, if point P go over here, you project down to the y-axis, it could be 0, right? The height equals 0, which means the midline right here. Alright, time t equals 1/12 plus 1/12 plus 1/12, right? So it could be 3/12. Simplify, it could be 1/4, right? So right here, it's going to be 1/4. Now, when point P goes back to the original spot, this is the highest point, right? So the highest point right here. Then time t should be 1/3, which means it's complete a full cycle, right? So this is going to be 1/3 here, and the height should be 15 right here. Alright, so now we need to calculate the amplitude. So amplitude equals maximum subtract minimum divided by 2, right? So 15 subtract negative 15 divided by 2. It's going to be 15, right? Now we need to calculate b, right? b equals 2 pi over the period. The period is 1/3, right? So then you're going to multiply the top and bottom by 3. So you're going to simplify this one. The answer is 6 pi, right? So we need to eliminate A and C and D. The answer obviously B, right? And you look at this one, this is a cosine function. Yes, it starts from the maximum values right here, right? Cosine function always start at the maximum value, right? Sine function always start at the midline, right? Now let's move on to example number 20. Right, so this one is similar to the example number 18. The only different thing is the starting point right here. Point P starts right here, right? Now, a sinusoidal function is used to model the x-coordinate, right? So, if point P right here, the x-coordinate should be the maximum point because the distance from here to here is 15, right? Distance from here to here, keep that in mind, it's going to be negative 15, right? So we need to sketch a sinusoidal function for this spinner, right? And this one should be the x coordinate. Alright, so now you need to find the period. So the period is time divided by number of rotations. So it's going to be 8 divided by 4, right? It's going to be right here. So it's going to be 2 seconds, right? We're going to take 2, we're going to divide by 4, right? So it's going to be 1 over 2 seconds for each quarter, right? And then next one, we have the period. We need to solve for b, right? b equals 2 pi divided by period, which is 2. So it could be pi, right? Now, from this information, we can eliminate the wrong answer, right? So wrong answer should be this. So the answer must be C, right? Now, we need to complete the sinusoidal function to make sure we understand it, right? So we start right here. This is the maximum point, so it should be right here, right? So at this point, t equals 0, right? Now, when the point P goes over here, you project down to the x-axis, it could be 0, so it should be the midline right here, right? So midline should be 0, this guy should be 15, this guy should be negative 15, right? And then time t should be 1/2, right? So this guy should be 1/2. Now, if point P goes over here, right? So time t should be 1/2 plus 1/2. It's going to be 1, right? So it could be 1 second, right? So 1 second should be right here. So because this point right here is the minimum points, because it's going to be negative 15, right? And if point P go over here, you project down to the x-axis, right? So let's go back to the midline, right? So because 0, right? So go back to the midline, it's going to be right here. And time t should be 3.5, right? Because 1/2 plus 1/2 plus 1/2 is going to be 3/2, right? So this one should be 3/2. And if point P go back to the original spot right here, it completes a full cycle, right? So it should be right here. And time t should be 2 seconds, right? And the point P right here should be the maximum point, it's 15, right? And the amplitude, we just use this formula to find the amplitudes, right? So maximum subtract minimum divided by 2, it should be 15, so it's 15 right here. Now let's move on to the next example. Alright, so given a table of data right here, we need to use a calculator to find the sinusoidal regression. And then we need to determine the value of the temperatures when time t equals 6 months, right? So we're gonna bring up the TI-NSpire calculator. Add list and spreadsheet right here, number 4. And then you just input the values, right? Alright, after we finish inputting the values for the table, now we need to hit Ctrl I. Hit add data and statistics right here. Hit enter. Alright, so we see that this is the scatter plot of the data, right? So we need to name the value for the x-axis, so it should be x right here, and name the values for the y-axis should be right here. Alright, so it's like sinusoidal function, right? And then you hit menu, number 4 right here, analyze, and number 6 right here, regression. And then it's gonna be this one right here, show sinusoidal. So here's the graph and the function. Alright, now we need to evaluate the value of the function at t equals 6, right? So we need to go to the home screen, right? Hit on right here, and make sure you need to convert it to radian, right? So hit setting right here, go to document setting, and then you need to change this angle to radian. So keep that in mind. Alright, so hit Control I, hit calculator. So you just hit 29.4787 times sine times 6, right? Because x was 6 months, right? And then minus and hit enter. So the answer is approximately 81.5486. So it should be C, right? Now I'm going to use the TI-84 plus C calculator to do this problem. Alright, so I'm going to bring up the calculator. Alright, so you need to hit start, edit. Alright, now you need to input the values, right? Now we hit start, count, right? We need to hit the upper arrow right here. And hit C right here, sinusoidal regression, right? Now iteration right here, the longer iteration, the more accurate. So I put this one as 16 iteration, L1, L2, the periods right here, because this information repeats every single year, right? So I put 12 months. Now go to store, I hit vars, yvars, function, y1, and go to calculate. Alright, so this is the answer, and it matches this information right here when you use the TI-NSpire calculator, right? Now I want to see how the graph looks like, right? So I hit second start plot, right? I need to turn this one on, so I need to hit enter, turn this one on, and then I hit graph, so it looks like this, right? Now I need to find the value of the function at t equals 6 months, right? So since I already stored the function, right? So I just hit vars, yvars, function, y1, and then I hit parentheses, set, close parentheses, and enter. The answer is 81.33, so answer must be C. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals, they take us higher. The night's young and it's just begun as she puts her hand in mine.